So let's learn a little bit about how event systems work and how they abstract away interrupts. So event systems. So they're basically an abstraction built on top of interrupts. Now, whenever you hear abstraction, you should realize, okay, what it means is it takes care of the mess, gives me an API. I just used a simpler, hopefully more useful API. That's what we mean by an abstraction. Now, a key thing about event systems is that they behave like interrupts. Okay, they're kind of like interrupts. They behave like interrupts, but nicer. You don't have to worry about your program being interrupted in the middle, and they give you a lot of features. So for example, they take your interrupts and they put them into a queue. Okay, this is really important actually. If, say, 4 behaviors happen at once, this guarantees the order of processing. Okay, so think about that for a second, right? If I get like a mouse press, a mouse move, and a mouse release, or a mouse move, a click, and a mouse press, you don't want those to happen in a different order. I'm going to come back to that. So they put them in a queue, which guarantees order of processing. That's really nice. They can also get sorted and pre-processed. Okay, into known types. Into data structures. So instead of dealing with bits and bytes and floats, you don't know what they are. You get like a mouse buttons data structure. Where you go mouse button left down, yes or no, mouse button right, that kind of thing. It can also tell you whether the shift key is pressed. This is very common. You get a mouse event, but it'll tell you, oh, the shift key was down while this is pushed. Oh, cool, you can get that kind of information. So it's like, they also give you timestamps when the interrupt happened, not necessarily when you're processing it. So you even if you're a bit late getting to it, you know when it happened and you can use that information. So this whole system, event systems, they take interrupts, they put them into queues, they pre-process them, they give them timestamps. This is all really good. In addition, you can add a lot of new features. Say you can add, for example, priorities. You can break the queue. Okay, these kinds of interrupts, I want them really fast. You can merge events. Okay, the mouse moved 400 times in the last 10 milliseconds. Let's just merge them into one mouse move event down to 10 milliseconds. That's good enough. And there's so many other features that you can do. Basically, you should realize that once we abstract away from interrupts and we do some processing, anything that we find useful, we can start building into this. You can also make new ones. You don't have to be interrupt driven. You can make new events. You can make high level events, user defined events. For example, maybe there's an event finished drawing, right? You want some code to be run when drawing has been finished. Another really cool thing is timers. You want an event to fire 10 times a second, 100 times a second, like the processing draw loop. So you can make these user-defined events. They don't have to be driven necessarily by interrupts of a hardware device. Okay? And they can also be application targeted. So filtered to specific applications. which is really nice in a windowing environment like Windows. You don't want every program reading from the mouse from raw and getting whether the mouse is clicked or not, or the keyboard. That's actually a security hazard. Only the program that's supposed to get it should get the event. So for example, if a mouse clicks on a window, or you're typing, only that program should get the event. So the event system can do that. They go, okay, the mouse is clicked. All right, which program, where's the mouse over? That program should get the mouse event, okay? So this is all really nice. They build on top of interrupts. They behave like interrupts, but a lot of the problems go away. And the other really cool thing is we can control when the interrupt, when it interrupts your program. I should say when the event. So for example, you're doing your draw loop, you're doing some draw. Well, maybe we shouldn't have an event interrupt us while we're doing draw. Why don't we just wait until we're done drawing so that the mouse position doesn't change, nothing changes while we're filing our code, we assume nothing changed, and then when I'm done my draw, we can handle my events. And with an event system, you can do that. You queue them up. You decide when you get interrupted with, okay? So one of the things that makes event systems, one of the troubles that people get into, but also makes them confusing to people, is the fact that they're actually single-threaded, typically. Event systems are often single-threaded. Now, if you've not taken operating systems, that might be a little confusing to you. So I'll explain a bit how that goes. But first, though, they're often single-threaded, and as part of that, this dictates when the events will happen. Of course. Okay, so they're single-threaded, which means that they're not being, things aren't working in parallel. It uses a single thread, so it'll run this event, wait till it's done, it'll run that event, wait till it's done, run that event, wait till it's done. So it has full control over. If you're handling a mouse event and someone clicks the mouse key at the exact same time, it's not going to interrupt you and start over like traditional events, which gets really confusing. Nope, it manages everything. And this makes more predictability. So when you're writing your code, you don't even think about what happens if another mouse click comes in while I'm handling this mouse click. What happens if they move the mouse while I'm handling this mouse move? No. The event system takes care of it. It queues things up. It's single-threaded. Nothing happens in parallel. It runs that event, then it runs that event. Everything is in order. And this is actually really important to know because if you're working on a system, many event systems or graphic systems, for example, they're actually will panic if you use multi-threaded programming to modify them. Okay? Will panic if another thread touches the graphics contents. Of course, this doesn't mean that you can't do it. It just means that you need to know about multi-threaded programming and how to signal and how to do things properly. If you're using, certain graphics libraries, it'll say, I forget what the exact error code is, but it'll crash. It'll say, warning, code was, accessed from a different thread. It'll crash because if we're working on the assumption that things aren't working in parallel, they're working one after the other in a queue, you can't break that. The whole program is no longer reliable. Okay, so you get a lot of programs with panic if you use multi-threaded programming and you're trying to access it. So if you try to touch graphics context or controls, and so forth. So the solution is actually not easy. It's complex signaling between threads. Okay, and this is beyond the scope of this course, unfortunately. Okay, so that's events. Event systems are basically the solution here. We haven't talked yet about how exactly you use them, but I want to, maybe it's a good time to stop here because we've learned about event systems as a way to abstract away interrupts. So they kind of work like interrupts. They act like interrupts. They can, when a mouse presses, it calls the code, but because we have that you've signed up for, but because we've wrapped it in this event system, we get a lot of additions like these user-defined events like timers. You can add pre-processing. It's sorted into mouse and keyboard. It's program specific. We get all of these things. We also get guaranteed order of operation. It won't interrupt if you're in the middle of your draw loop and the interrupt comes in. It won't block your draw loop and go off and handle the interrupt. It'll make sure it finishes your draw loop first before running the event. Now, if you're curious about how that works on an operating systems level that's beyond the scope of this course, come talk to me. I can explain how it works. But the key point here is we've gotten rid of a lot of the problems with interrupts and moved it into an event system, which makes it serial, one event, then another, and helps us pre-process those events. Okay, so we'll come back and we'll learn a bit more about exactly how interrupts work. How events work.